In our first example, using the half angle identity, we want to find the exact value of cosine 15 degrees. We have found the cosine of 15 degrees already in a different section using the cosine of a difference. We rewrote cosine 15 as cosine 45 minus 30. And then we expanded using the cosine of a difference identity. We're going to get an answer that looks different but has the same value. If you type the answer that we get and the answer that we got for cosine 45 minus 30 after we did the expansion, then those decimals would be exactly the same. So since the forms are going to be different and the forms give us the exact value, then if they tell you to use the half angle identity, then that's the one that you have to use. If they tell you to use sum or difference, then you would use the other one. So let's look at cosine 15 degrees. 15 degrees is half of a special angle. It's half of 30 degrees. So let's rewrite this in our half angle identity form. We have cosine 30 degrees divided by 2. 30 divided by 2 gives me the 15 degrees right there. Now let's write the other side of that identity, where our A is 30 degrees right here. So we have cosine A over 2. And on the other side, we get plus or minus the square root of 1 plus cosine. Remember, if this is A over 2, this is A right here, so 30 divided by 2. So this angle is twice this angle right here. Now we need to choose the plus or the minus because we can't have them both. And this plus or minus doesn't depend on this angle that's on the inside because nothing outside the radical impacts what's inside. This plus or minus comes from what quadrant this original angle is in. 15 degrees is in quadrant 1, and so we're going to choose the positive square root because everything is positive in quadrant 1. And then the next thing we have to do is to substitute in a value for cosine 30 degrees. That's a special angle, so we use our hand trick to find that, and cosine 30 degrees is the square root of 3 over 2. And then that's all divided by 2. Keep in mind that on the half angle identity, that's a big radical. It covers the numerator and the denominator. Now I've gone from having trig in my expression to just having numbers in the expression. And really this is the more complicated part because you have to be able to simplify this without making any mistakes. When you have a complex fraction, which means a little fraction inside of a bigger fraction, then one consistently easy way that you can get rid of that complex fraction is to multiply top and bottom of the big fraction by the baby denominators, every factor of every baby denominator. We only have one baby right here, so if we multiply top and bottom of the big fraction by 2, it's going to clear that little fraction. Now we do have to multiply both terms of this numerator by that 2. So when you do that, 2 times 1 gives you 2 right here, and 2 times that fraction, the 2's are going to cancel, and I'm left with square root of 3. So baby fraction is gone. I have to remember to multiply the denominators as well, so that gives me 4. When you have a fraction under a big radical like this, you can apply the radical to the numerator and to the denominator separately. So that's our next and last stage of simplifying this. So in the numerator, square root of 2 plus square root of 3, and in the denominator, square root of 4 gives us a 2. Now it looks a little weird to have radicals underneath radicals like that, but there's nothing you can do to simplify that. It's okay to leave that answer like that. You should expect answers like that when you're using the half angle identity. It's not okay to have radicals in the denominator. You have to rationalize, but it's okay to have them in the numerator